Hello and welcome to Mrs. Law's class. In this lesson, we're going to take a look at how to derive the geometric sequence formula and then also how to apply it. Now, before I start, I want to apologize because you might hear some hammering in the background as the neighbor is actually building a house. All right, so to start, a geometric sequence is where each successive term is obtained by multiplying the previous term by a common ratio, which we will denote with the letter R. So if you take a look at the sequence here, we can find R, the ratio, by going 6 divided by 3, so the second term divided by the first term. We can even take the third term divided by the second term, which is 6, or even the fourth term, 24, divided by the third term. You'll notice that the common ratio is always going to equal 2. All right, so the formula, before I tell you exactly what it is, let's see if we can derive it. So let's say the first term is T1. The second term can be T1 times the ratio. The third term can be T1 times R, and then times R again to get the third term. So we can say this is R squared. And so on. The fourth term would be T1 times R times R times R. So this would be times R cubed. Now writing this out vertically, we have T1 is T1, T2 is T1 times R, T3 is T1 times R squared. So if you look at the pattern, you can see all of them have a T1, and then it's times R, and you'll notice that the exponent is 1 less than the exponent of the term we're looking for. So our general formula can be T1 times R, and then n minus 1. So Tn, that stands for our nth term. T1 is our first term. R is the common ratio. And then n is the number of terms. So notice the number of terms is n, and we are looking for the nth term. So let's take a look at an example. In this first example, we can see that it's a geometric sequence because 16 divided by 8, 32 divided by 16, and 64 divided by 32, all of the ratios are 2. So we're going to write R equals 2. So we're looking for the 12th term. So T12 is equal to the first term, which is 8, times the ratio, which is 2, to the power of 12 minus 1, since we're looking for the 12th term. Now be careful, we're not going to go 8 times 2 to give us 16. Because we have to do order of operations first, we have to do the exponents. So we have to go 2 to the power of 11 and then times 8. Now of course you have a scientific calculator, so you can multiply all of this out, and you should get 16,384. All right, let's go to a different type of example. You'll do all the part B's as your turn for you to practice. All right, so for this one here, I'm actually going to list all the different things we have. So we do have our T1, which is 8. We know our ratio, which is 16 divided by 8, so that's going to be 2. N, we don't know how many terms there are, that's what we're trying to find, but we know that nth term, because the 131,072 takes the place of what that term is, or how many terms there are. So plugging all of this into our formula, we get 131,072 equals 8 times 2 to the power of n minus 1. Now again, we don't go 8 times 2 first. We have to divide both sides by 8. So we do that, and we're going to get 16,384 equals 2 to the power of n minus 1. So divide both sides by 8. All right, now you'll notice that n is in the exponent, so we'll have to do something that we've learned before, which is we need to log both sides so we can bring the exponent down. All right, so we're going to log the 16,384. We're going to log the right side, but remember when we do that, the n minus 1 comes down to the front. So we'll have n minus 1 times log 2. And now we're going to divide by sides by log 2. So we have n minus 1 equals log 16,384 divided by log 2. You're going to go to your calculator and figure out what that is. So we'll have n minus 1 equals 14. Add 1 to both sides, so n equals 15. Okay, and so that's how you find the number of terms. And remember that when n is in the exponent, we'll have to use logs to solve for that. Next, we're going to take a look at something called the geometric mean. So the geometric mean means the terms in the middle or in between in a geometric sequence. So let's say we're given the geometric sequence A, B, C. We can find the ratio by going B divided by A or C divided by B. So if B is the geometric mean, we can find this by going B times B. So we're going to cross multiply. So B squared equals A times C. And then square rooting both sides, we have B equals the plus or minus the square root of A times C. All right, so let's see how to use this. So between 8 and 128, let's insert one geometric mean. So that means we want to find one number in between 8 and 128. So we can say B equals plus or minus the square root of 8 times 128. Plug this into your calculator, and you get plus or minus 32. And it can be plus or minus because remember we can go 8 times positive 4 to give 32 times positive 4 to give 128. Or we can go 8 times negative 4 to give negative 32, and then negative 32 times negative 4 to give 128. Now another way that we can do this problem, let's say that we wanted to insert more numbers in between, then we can't just use the square root. So we have the first term is 8. Our r is what we don't know. We have 3 terms in the sequence, and we know that third term is 128. So inserting the numbers into the formula, we get 128 equals 8 times r to the 3 minus 1. So we get 16 equals r squared. So r, we're going to square root both sides. And don't forget, when we do this, we get the plus or minus. So r equals plus or minus 4. So again, we're going to get 8 times positive 4, which is 32, and then 32 times positive 4, which is 128. Or we can go 8 times negative 4 to get negative 32, and then negative 32 times negative 32 times negative 4 will give us positive 128. So again, our middle term, or one geometric mean, or I should say 2 geometric means, is positive 32 or negative 32. All right, and you can try the other ones on your own.